Let's have one last example in illustrating limit superior and limit inferior. And for this, let's have a piecewise function or a piecewise function that will indicate our given sequence. What if it's in this form? N, if n is a perfect square, my bad. It should be n if it's a perfect square. Then it's this expression otherwise. Okay? So let's have this piecewise function that to indicate our sequence. So that would mean the elements of this sequence is, since 1 is a perfect square, so 1 for all natural numbers. If it's 2 otherwise, so that's 1 as well, because we'll be using this for 2 because 2 is not a perfect square. So the square of -1 is 1. Okay. For 3, we have -1 here. Take note, this we are going to use this as well. For 4, since 4 is a perfect square, so we'll have here n itself. 5, so 5, that's positive, so you have, add, so you have negative here. For 6, 6 is not a perfect square number, so this will become +1. 7, 8, 9 is a perfect square, so n itself. And so on and so forth. Okay? So let's determine the limit superior and limit inferior of this given sequence identified by this piecewise function. So for the limit superior of x sub n, it's the infimum of the set V. So let's start identifying first the elements of set V as the supremum of the entries here, depending on where we start. So let's start here with the first one, combining all or containing all. So you have here 1, 1, -1, 4, -1, 1, -1, 1. So I'm writing all to illustrate my answer here. So you can use here bracket if you would like to. The supremum is the greatest, the least upper bound. As you can see, we have here positive values, and if we're going to continue for n being a perfect square, and since natural numbers is infinite, so we'll have also infinite value for our perfect square, right? So that would mean this is positive infinity, because we don't know its exact value. It's very large. That's the supremum of your first. Okay, next, what if I have here, this is considering the second to the next. So you have +1, -1, 4, -1, 1, -1, 1, and 9. Same thing here. We have infinite value for infinite numbers of natural numbers here. So this is also the least upper bound is also infinite. It's very large. Okay? So we're going to continue the supremum. We have -1, 4, -1, 1, -1, 1, and then 9. Again, same thing here, positive infinity. And even if you're going to reach for S sub n, the supremum of that, I don't know what to denote, because this is both of them are acceptable. So the supremum of whatever will be the S sub n, okay, is also positive infinity. That would mean, in this case, the limit superior of your x sub n, which is the infimum of all these values, positive infinity, until positive infinity, the limit superior is positive infinity or just infinity itself. Hence, the limit superior of your x sub n is clearly positive infinity, or again, just infinity is okay. Hey, that is for the limit superior. As for the limit inferior of your x sub n, it's a supremum of all whatever the value of this, so of the infimum of that. Okay, so let me rewrite here the elements of x sub n. Okay, just to be guided, sorry for that, let me rewrite that one. So you will have here x sub n, copying this, hopefully I can memorize that. 1, 1, -1, 4, next is -1, 1, -1, 1, 9, and so on and so forth. Okay, so from this you will have here the starting one, the infimum of this entire form: 1, 1, -1, 4, -1, 1, -1, 1, and then 9. Okay, So the infimum of that, which is the greatest lower bound, is negative 1. Okay? Because that's the lowest, or again, the greatest lower bound. If you have your I sub 2, the infimum, starting with the second, 1, negative 1, 4, negative 1, 1, negative 1, 1, and then 9, and so on and so forth, is still negative 1 here. Okay? For the third, this is I, pardon for that. Okay? The infimum of, we'll have negative 1, 4, negative 1, 1, negative 1, 1, and then 9, and so on and so forth. It's still negative 1. Even if you're going to reach here, for your I sub 4, the infimum is still negative 1, because negative 1 will appear to be the lowest value, and in this case, the greatest lower bound because of this notation. So with that, the limit inferior of x sub n is the supremum of all these entries, negative 1, negative 1, negative 1, until negative 1. So it's negative 1. Again, the limit inferior of your x sub n is negative 1, which is different from your limit superior. And again, we have a theorem indicating whether the bounded sequence is convergent or not, and we'll have that in a separate video. Thank you very much for watching.